Find the derivative of y equals the cubed root of 4t squared plus the square root of 5t cubed minus the square root of 7. Y here is made up of three terms combined by addition or subtraction. The cubed root of 4t squared plus the square root of 5t cubed minus the square root of 7. We can therefore do the derivative of each of the terms separately and combine the results by addition or subtraction accordingly. The first term, I'm going to need to separate the 4 from the t squared to isolate the t so I can use the power rule. It will be the cubed root of 4 times the cubed root of t squared. The second term, I'm going to need to isolate the t cubed away from the 5. In the same fashion, we'll have the square root of 5 and the square root of t cubed, and then minus root 7. So y will equal the cubed root of 4 times the cubed root of t squared, which is t to the 2/3, plus the square root of 5 times the square root of t cubed, which is t to the 3/2. Power of 3 and root is square root, or the second root. And then minus root 7. What I've done is I've changed the terms into a form that is now more useful for the power rule, which can be done for each of the first and second terms. And now we can take the derivative. Y prime, which can also be called dy dt, equals to, the cubed root of 4 is just a constant, so that's just going to come along and multiply, bring the power down, 2/3, and then t to the 2/3 minus 1, which I will write as 3/3. Plus the square root of 5, which is just a constant. Bring the 3/2 down, and then t raised to the 3/2 minus 1, which I will write as 2/2. The third term, negative square root of 7, is just a constant. There's no t's. And the derivative of a constant is going to be a 0. So y prime, or dy dt, can now be written as, multiplying, I can think of the cubed root of 4 as being over 1. I will have 2 times the cubed root of 4 over 1 times 3, which is 3, and t to the 2/3 minus 3/3, which is negative 1/3. For the second term, I can think of the root 5 as being over 1, so I will have 3 times the root 5 over 1 times 2, which is 2. T to the 3/2 minus 2/2, which is 1/2. That negative exponent can be moved to the other position. Right now it's in the numerator. It can move to the denominator. So I will have 2 cubed root of 4 over, it'll move to the denominator with the 3. 3t to the 1/3 plus 3 root 5 t to the 1/2, which is in the numerator, and it's not a negative exponent, so I'm not going to move it to the denominator. And one more step, we can write this as 2 cubed root of 4 over 3, and t to the 1/3 is the cubed root of t to the first power, cubed root of t, plus 3 root 5, t to the 1/2 is the square root of t to the first power, or just square root of t, and then all of that over 2. We're now going to evaluate y prime of 1. That means to plug a 1 in for each of the t's. 2 cubed root of 4 over 3 cubed root of 1 plus 3 square root of 5 square root of 1 over 2. Now any root of 1 is going to be a 1, so we will have 2 cubed root of 4 over 3 times a 1, which will just be a 3, and then 3 square root of 5 times the square root of 1, which is a 1, and then over 2. The only other thing that we can do here is get a common denominator. We have a 3 and a 2. Common denominator will be 3 times 2, it'll be a 6. We can multiply this first fraction by a 2 over 2, and the second fraction by a 3 over 3. So 2 cubed root of 4 over 3 times 2 over 2 plus 3 square root of 5 over 2 times 3 over 3 will give us, multiplying the numerators, 2 times 2 is 4 cubed root of 4 over 6. For multiplying the denominators, 3 times 2, plus multiplying the numerators, 3 root 5 times 3 is 9 root 5, and then over 6 by multiplying the denominators, 2 times 3. They're over a common denominator, and now they can be combined. 4 times the cubed root of 4 plus 9 times the square root of 5, all divided by 6.